Okay, everybody, I want you to notice my school spirit today. I don't usually wear UVU shirts, but hey, it's my math week from 2015 shirt today. So anyway, I don't know when that is, but hopefully it's coming up soon. So we're going to finish 4.3. I want you to know, have you noticed that I've been going slower on this and the logarithmic stuff? Is that helpful?
Yeah.
Yes.
Okay, because this is probably the hardest stuff you're going to learn all semester. And I didn't realize, but we could have, well, we're almost done. The main thing I want to talk about, we have common logarithms, and we have natural logarithms. These are the two most common logarithms that you're going to use in real life. Common logarithms are base 10, and natural logarithms are base e. Okay? On your calculator, you'll notice that you have two buttons. If it just says log, with no base, we assume it's always base 10. And that's what your calculator has. If you have an ln button, we assume it's base e. And this could also be written as log base e, but we usually write it as, I guess if you're French, logarithm naturel. Okay? So one of the nice things about base 10 logarithms is you can, if you have a nice round number like that, if I said the log of 10,000, count the zeros. That's 5. It's really nice. Log of 100. How many zeros are there, Natalie? 2 zeros. So those are nice and easy.
Wouldn't that be 4? The one
Yeah.
What's that? Oh, sorry, I can't count apparently. Yeah, it's 4. Okay. Some of you are better counters than I am, clearly. Okay. So it doesn't get so easy though when you do the log of 213. That one's not, so you can't count zeros very well on that one. But I do know, and log of 200, or not 2100, 200. That one's not so easy. God, I can't write. Log of 200, don't just count the zeros then. That doesn't work. Okay? So, but yeah, if it's a 1 with a bunch of zeros, just count them. Count them better than I do. Okay? All right. Let's see here. I think that's it. Oh, there's a couple more things.
If you had the log base 10 of 213, would you just turn it into an exponential equation?
You could. What would the log of 213 be if you had an exponential equation? 10 to some power of x equals 213. Now you know that 10 squared equals 100 and 10 cubed equals 1,000. Okay.
I narrowed it down.
Yeah. So you know that the answer is in between 2 and 3, and it might be easier just to plug it in your calculator. Figure out what that one is.
Right.
Okay. But you don't. But you should get. Hopefully, you get a number between 2 and 3, because it's in between 100 and 1,000. So, if you can guess, my guess would be 10 to 2.2 power. Anybody got a calculator? Tell me what that is. Let's give that. See how good a guess right.
It's like 2.3.
What is it?
2.3-ish.
Is it 2.3-ish?
Yeah.
Is it 2.3? So yeah. So you could rewrite this as 10 to the 2.3 power equals 213. Now, generally, what I will say when you're using this, you probably do want to round to 4 decimals. So plan on 4 decimals, because otherwise you cut off too much. So, and of course, it's easier just to do the log of 213, right? What's the log of 213? Give me 4 decimals at least.
2.3283.
Okay. So 10 to the 2.32 3283 equals 213. That's all that means. Okay? All right, let's just do a couple of these. I think this one might have been on the quiz today. I can't remember, but ln of e to the 8th. Can you do that without a calculator, Fidencio? You should be able to do it without a calculator.
Should.
What do you do with the 8?
Oh, put it,
Out
yeah,
front.
behind the
And the ln of e is
1.
1, so the answer is 8. Okay? How about the ln of 1 over e squared? Let's make sure you guys are good on this. Alyssa. Oh, you should. How could you write that without a fraction?
Could be e squared and then
ln of e to the -2, right? Okay. And then what do you do with the -2?
bring it up front.
Bring it out front. What's the ln of e?
1,
1. So therefore your answer is
-2.
-2. Okay. How about the ln of 5? Sam can do that one in his head, right?
It will be 5.
No.
Alright.
I was joking when I said you could do that one in your head. Can you do it with a calculator?
.6094.
Can you do that in your head?
No.
All right, how would you write that as an exponential equation? This equation right here.
It will be 5 to, no, it will be e
E
to the 1.6094
equals
5.
5. Okay? Those are similar equations. Okay? That makes sense?
Do we need to put like a symbol of almost equal, like in the exponential, or is that okay?
What's that?
Like we need to put that symbol of almost equal, like
Similar, kind of like an equal sign that's curvy.
yeah.
Yeah. Okay? All right. Oh, now this is the best one. We haven't spent a lot of time on this. I actually probably want to spend more than one problem on this because they love to put this on the final exam and students love to miss it. Okay? What if I told you I wanted you to find the domain of ln, sorry, I should write it correctly, f of x equals the ln of 4 minus x squared. Okay. And like I said, this is a really popular final exam question. So that means you better learn it. Okay? So Eric, what do you think?
I have no idea.
No idea. How about James in the back? Negative infinity to infinity is not correct. Okay? So let me ask you the question this way. What causes you grief when you're doing logarithms? Everything? That's a true statement, probably.
So it is -3.
Okay, so we don't know? That's bad. We gotta learn this one by the final exam, hopefully by the next test. Some of you are gonna wait till the final exam to learn this, though. I have a feeling, okay?
Factor that out, solve for X.
Factor it out and solve for X.
No?
Not exactly. You are gonna do some factoring, but that's not where your mind should go, okay?
Yes.
What is the ln of -3? Can you do that one in your head, Patrick?
ln of -3?
Yeah. Pulls out the calculator,
Yep.
and he gets
Undefined.
undefined. That was a good answer, even though it took a calculator. You should have known that beforehand. Okay, let's think about this for a minute, okay?
You cannot take
If I did the ln, if I wanted you to graph ln of x. And it's been a whole weekend, so we've probably forgotten how to graph already, right?
so the asymptote will be
Okay.
x equals 0.
Would you say?
Asymptote will be x equals 0.
Say it again louder.
The asymptote it will be x equals 0.
Asymptote is at x equals 0.
Then the magic point is going to be
The magic point, I like that better, actually. That's better than important point. At 1, 0, and it looks like,
0, and
you can
then
hand draw it if you want.
It's gonna go.
Yeah, it's gonna go like that, right? Okay, so this is your normal standard logarithmic function, ln of x, log of x. If you draw something like that, it's got an asymptote, it's got the magic point. I like that even better, even though it's not really magic. And the basic curve here. Now, what does this tell you? If you were to look at this graph by itself, ignore my problem for a minute. If you were to look at this graph, what's the domain?
0.
Okay, your domain is x has to be greater than 0, or if you like 0 to infinity, I'll take that. And is this a square bracket or a round bracket? It's round because it cannot equal 0.
Nobody marks as an element of,
Okay? What'd you say?
you're half correct.
No, that's fully correct. That is fully correct for a domain. Okay? Oh, you're talking about this part. Sorry. Yeah. Okay? All right. So, this is what you should remember for all logarithmic functions. The domain is always going to be x is greater than 0. For a generic logarithmic function, if that's at log instead of ln, this still applies. Okay? So as we go back to here, whatever's inside the parentheses, what does that have to be greater than? So 4 minus x squared has to be greater than 0.
Just solve it that way.
Okay? So that's the key. Okay? So whenever we're talking about logarithmic functions, whatever is in the parentheses has to be greater than 0. Now let's think about this. Forget the logarithm for a minute. This has to be greater than 0. What does this look like? It's a parabola, right? And you know how to graph a parabola. What does a parabola look like? What does this parabola look like?
It's going down, it's going to be, yeah.
Yeah, we're going to move it up 4, right? 1, 2, 3, 4. It's going to be downward facing. Now, these intercepts are going to be very key. We need to know what those are. What are those intercepts? If this was strictly an equal sign, we'll change it to an equals for just a moment. What would it be? What? Add x squared. 4 equals x squared. X equals 2. Don't say 2. Plus or minus 2. You can't forget the plus or the minus, right? It's going to be minus 2, and it's going to be plus 2. Now, I've drawn a graph of the domain. I haven't drawn a graph of the function. Okay? Remember, this doesn't equal 0. It has to be strictly greater than 0. Where is my graph greater than 0? Where is my parabola greater than 0? It's above, right? All of these are valid numbers. All of these are not valid numbers. Okay? So my domain of this is what? What are all the possible x's I can pick? I can go all the way to negative 2, positive 2. That's your domain. And if you wanted to write that in interval notation, because I know that Danae wants to do that, you can tell by the look on her face as she looked down and she was hoping I wouldn't call on her. How would you write that in interval notation?
So you'd go negative 2 with a parenthesis, and then comma 2 parenthesis. Or x is the element.
X is an element of. Thank you. Ooh, that looks terrible. X is an element of. Hard to write sideways. Oh, as I trip over my bag. Okay? Does that make sense?
Yeah.
I really was going to start 4.3 today. But here's the problem. Guaranteed they're going to put, not guaranteed, 90% sure they're going to put a problem with a logarithm and they're going to ask you the domain on the final exam. And I really want my class to do well. Even if you don't, I do. Okay? So let's do another one. I was really planning on going to 4.4 today. And hopefully I gave you, did I give you enough domain things? You know what, I only gave you 4 domain problems. And the 2 that I didn't give you are even better. We're going to pick one of those, okay? Because I wanted you guys to do really well on this. Okay, this is problem 77, which was not assigned, but I kind of think it should have been. If we have time, I'll do, I don't know if we will, 78. Which one would you guys rather do, 77 or 78? Which one looks harder?
78.
78? 78, h of x equals, this actually is a better problem. Square root of x minus 2 minus log base 5 of 10 minus x. Find the domain. Okay, let's break this up into pieces, okay? We've got that piece and we've got that piece. So if we ignore this for a minute, what's your domain here? I don't care about the square root, right? I can make it the square root of anything. It's only what's inside the square root that's 2. Okay, so x minus 2 must be greater than, only greater than? It could equal, right? That would be okay. What?
0.
0. So x is greater than or equal to 2. Okay? The square root's kind of the thing that I have to pay attention to this piece. Now let's look at this piece. What is my problem part in here? Ignoring this, what's the problem with my logarithms? What causes me grief? 10 minus x must be greater than, can it equal 0? No. This is strictly greater than 0. So if I add x, x has to be less than 10. Okay? So we can see from this piece, x has to be greater than or equal to 2, and from this piece, x has to be less than 10. This was a good one. I'm glad we did it. We might do the other one. So between these two pieces, what is the domain that works with both functions essentially? And I'll let you do it in either regular notation or exponential, whichever you prefer. Patrick.
X is a function of bracket 2.
X is an element of
Yeah. Element of bracket 2.
bracket 2
Parenthesis 10.
and 10 parentheses. Perfect. Okay? Now, I'm just going to warn you, most people don't write it that way, but they do like it on the final exam in this class. Okay? How would you write that in regular notation?
2 is
X has to be between
2.
2 and 10, and that's an equal, and that one's not. Okay? X has to be between 2 and 10. It can equal 2, it cannot equal 10. It can equal 2 here, that's fine, and 2 is not a problem here. It can equal 10 here, 10's completely fine, but you got a problem if it's 10 there. Does that make sense? Okay? All right, one more problem. We'll do the other really hard one that I should have assigned. Okay? Really, we should do more domain problems because this comes up on the final and you guys don't do enough of these. ln of x plus the ln of 2 minus x equals some function h of x. Okay? So, Max, let's break this up into pieces. Okay? If we just look at that piece of the function, what would be your domain in that case?
X is greater than 0.
Greater than 0. Okay, well done. If we just look at this piece, Eric, since I let you off the hook earlier, putting you back on the hook, what's the problem here?
Cannot, or X cannot be.
Well, let's not just go with x. Let's take this whole piece here. 2 minus x must be
More than 0.
greater than 0, right?
Yeah.
How do I solve that?
2 is greater than X.
Yeah, add x. 2 has to be greater than x, or rather, it's easier to say x is less than 2. So x is greater than 0, and, maybe I should put a nice and in there, x has to be less than 2. So the overall domain for the entire function, Derek, is
Greater than 0 and less than 2.
x is greater than 0 and less than 2. Okay? And other Derek, can you write that in interval notation?
Would it be, so x is an element of, would be parenthesis 0, or, yeah, 0, -2?
Negative 2,
Just 2.
final 2. Round or square? Round, we're out of time. Okay? Does that make sense? Okay? I only assigned you 4 of these. I can guarantee one of those 4 is going to be, maybe one of these 2 also, is going to be on your quiz tomorrow. They really want you to do well, and they love to put this on the final. Yes.
So quick, as a general rule, how do you know if it's greater than or greater than equal to? That makes sense.
How do you know it's greater than, rather than greater than or equal to?
Because if it was equal to,
So think of this. Let's just graph that for a minute.
if it was equal to 0, then you have.
You've got an asymptote at 0. So it's got to be,
Got it.
can't equal 0. You got a problem.
I mean,
Okay? On a square root, there's no asymptote, right?
Right.
Square root function looks like that. So it can equal 0.
Got it. Okay, and that's what, is that why we can go to square root?
Okay? See y'all tomorrow.
Thank you.
Guys.
Thank you.
Oops, cancel.